Good morning. Well, it's a Sunday morning. It's just starting to get a little bit too warm for my liking outside. The cats have the zoomies, so if anyone hears a crash and glass breaking in the background, you know what's caused it. And yes, it will give me a panic attack. Anyways, let's get back to what we were working on. Now, in the last episode, we had a weird issue when we were drawing to the screen where it was just columns with some garbage on the left-hand side. And I'm wondering how many eagle-eyed people caught the fact or caught the issue, which was that I had an ampersand here. For those not familiar with C++ or C, an ampersand is a way of getting the address of a variable. You put an ampersand in front of it, and there you go. You've got that variable's address. So instead of sending it the pointer that I was tracking to our buffer of video data, I was sending it the variable's location in the data segment, which is why only the first couple of columns were changing value, because that was as things were changing value on, I believe, the stack, because this is a local variable, isn't it? Yep. So what you were seeing was actually just the value of VB and the value of I incrementing. And I do believe it was the first 6 columns of pixels, or 6? Yeah, I think that's right. Because the first 6 columns were counting, and in fact, you can, if you go back and pause it, you can actually see that they are just incrementing through the palette in a very linear fashion, and then you'd get the next 153 or 150. Am I doing that right? 154 bytes of memory just being, and that's whatever was in stack. It was random. So what I should have done was just written VB so that it would pass the value that we're storing as the address I wanted to send. So with that fix done, rookie mistake, as it is. Oi, that's what happens when you take a break from programming and then you try coming back and using something like these old DOS programs that don't do any code highlighting, and you're like, oh yeah, my code is fine. But there you go. We have graphics, so that is like the biggest hurdle right now, is just getting a image to the screen. Now, unfortunately, though, that's just a single image. And we don't actually do any kind of file verification. So we might get a file that isn't in the correct format. And that's going to kind of mess up what we're looking to do. So actually what these two commands are, and we'll go ahead and add in their functionality right now. So this is, we're reading in what is often called a magic number. It's just in this case, a 2-byte identifier to make sure that the file we're opening is actually the kind of file that we're looking for. The idea being that if you just threw any file and gave it the name that we're looking for, res0.dat, doing a magic number helps reduce the possibility that we're going to have, like, say someone just threw in a PNG or a .mid file, or God forbid a DLL, and called it res0.dat, because, if you're going to figure out ways to break systems, that's something that you do. Just reading in the magic number, and in this case it would be if not 0x. Oh, I forgot to turn that back on. What was I doing? 0x 6002, which is a number that I made up. There's no rule that it has to be 6002. That's just what I chose, and that should be. You know what? I am really just not thinking this morning. If I doesn't equal 6002, ideally we would set up some kind of error condition and maybe we'll go ahead and add that then today. So what we'll do is we'll say error, and we will pass a uh, something that we're going to define. So we're going to say invalid screen, and then we will say backslash. Actually, I won't worry about the backslash n because I can add that in later. We will say %s, and we'll say, oh wait, I don't have to do that because in this case we have a hard-coded file name. So we're going to go ahead and flag our error and then return. File, save. And then this is the second word in our file is going to be the total number of entries that we were expecting to have in this. So read in entry count if I is less than ID. Okay, it's lowercase ID. Then we will also send an error of type invalid index, entry %d does not exist in res0.dat. Return. And this is a void, right? Yeah, that's a void. Okay, so that does our error testing. I'm also going to eventually add in another type of file, because, or I might actually just replace the file that we're looking to use, because this file format is very easy to load because it's just the video buffer kind of stored in a file in the form of 32K. Or I should say 32,000 bytes, because 32K is an ambiguous term, especially on old systems. 32K now is supposed to be 32,000 bytes, but traditionally it has oftentimes been used to refer to 32,768 bytes. So we are going to say 32,000 bytes. And we're also going to go ahead and fseek, and I hope that I'm doing this right. In fact, let's go ahead and fseek. Alright, how do I maximize the window? Zoom, F5. There we go. Okay, so, see? Stream goes first, then offset, then our actual location. So, F. And we're going to say I times 32,000. And multiplication is kind of expensive on old computers, but we're only doing it once to load up our background image. And we'll probably eventually split rendering the background image to screen out away from our loading operation. That way we can kind of get a little bit more complicated with things when we start moving into rendering sprites and text and what have you. But there you go. There is our... This should... I'm just going to go ahead and... Oh, no, that's wrong. Oh, because I haven't specified those, right? Yeah. No, that is correct. That is correct. It's not seek set, it's seek current. Okay, so now we need a new file. This is going to be our error file, real quick. So, edit, copy. I'm going to edit, paste, just so that we're a little bit okay, a little bit consistent. system. Alright, so what we're going to need in this is we're going to need a couple of things. One, we're going to need a buffer error message. And I'm going to give it 64 characters. I figure that's probably a safe length. I'm not looking to be printing too much information out at any given time. And we do not need to set it, because it's not going to have any value. Error ID. So then we want void error. And it's going to be int capital ID char star format ... Alright. And now one of the things that I like about C is the ability to do arbitrary lists of parameters. Is it the cleanest way to do things? Probably not. Do modern languages do things better? Probably. But you know what? It's fun. I like doing this. So now, because these are like super esoteric, I need to look up the exact... There we go. VA list. Oh, come on. Where's VA start? There we go. All right. In fact, actually... Oh. All right. Yeah, there we go. VS printf. Yeah, sorry. I do have this emulator set to the to approximately 8 megahertz. I say approximately because in DOSBox everything's always kind of, you know, a little bit a little bit special. Okay, so the way we're supposed to use this... No, you went past. Okay, so the way we're supposed to use this is we define our VA list. We tell the system with this macro, the VA start, where in the stack that VA list starts. And then when we're done, we say VA end against the VA list, and that will kind of clear up any overhead that the VA that C generated when we ran VA start. And then VS printf will allow us to copy our formatted message, any arguments in the arg list into our error buffer. So let's go ahead and get that implemented. So VA list args, VA start, VA, or sorry, args, and format. And I, of course, cannot remember because I've got the memory of a goldfish. Am I being stupid? VA start. Okay. Don't have to pass any, Okay, cool. I was just making sure I didn't have to pass any, anything by reference or just value was good enough. So VS printf, we go error message format args, then VA end args, and we also want to store our error ID equals ID. All right, so then we need something to test for error. So we'll say get error ID, and that should be of type int. Return error ID. Oh. And then void, actually no, not void, char star get error, which will return our error message value. Okay, so that should be everything that we need. And this is probably a little overkill. I usually actually do one monolithic header file, but for right now, we're going to do separate header files because I like complicating my own life. So we will say that and then say new. And we are going to do our pound if and diff error h, then define error h. And then we will have void error int char star format dot dots. Okay, then void get error ID, which is not a void, it's an int, and then char star get error with extra r's. And then endif. File save as. This will be error.h. All right. You know what? Is there a way to go backwards through it? No, just forwards. Okay. Okay, so then I need to save as error.c. All right. And then project. We need to go over and select our project file. Oh, and I still don't have the error codes that I've defined. So first off, let's go ahead and close the project. Yes. All right. That way our new file addition to the project gets saved. And then it recreates all of our windows. Okay, so what I need to do is I'm going to go ahead. Actually, let's go in here and say, so we're going to need to check to see if there was an error. So we say if get error ID doesn't equals, actually I can just say if get error ID, then printf, and I can hear someone saying, are you doing that again? Are you sure? Percent well, we'll go ahead and say 08x, right? 8. No, 8 digits is for a 32-bit value, so 4x. Error. And then %s \n. And we will say get error. Sorry, get error ID. Get error. All right. So, and what we'll do is we'll go ahead and just to make sure that the error system is working, we'll say error, and we'll say 10, which will come up as an A. We'll say no error. File save. Okay. Now, I do need to go back into video, come down. So we've got error invalid screen and error invalid index. So we need to give those some kind of value. Doesn't matter what the value is, but we need them to have a value. So let's break out our trusty define statement. Error invalid screen. Actually, let's genericize that and say invalid file. We'll make that 0010. There you go. A nice round 10. Define error invalid index, and we'll make that, why not, let's make it 11. File save. Alright, so I think we can go ahead and close video.h for the moment. Now what I do need to do is, before I compile, I need to add a reference or an include for error.h, and I want these to be in alphabetical order because I am prissy like that. Error.h. Save. And then we come up here somewhere. And we say include error.h. Okay, so file, save all. Make. Oh, what have I forgotten? Oh, right. Oh, that is foolish of me. Pound include stdargs.h. File save. Compile. Make. Oh, I have even more. Okay, what is that? stdarg. Singular. I'm always adding pluralization to things that don't need pluralizing. Undefined simple error. Okay, no, that's fair. That's fair. That is an honest-to-God typo, and we should always set error ID to 0 just to make sure that if error is never called, we do know that we have the 0 value, which is our no issues detected. So let's go ahead and come back here. I am going to you know what? No, I'm not going to say if not. We'll say if error ID equals 0, because that's a little bit more, it's a little bit more straightforward. It's easier to read. Okay. Oh, still have an error. Oh, right. I forgot to rename that in this. Invalid file. File save. Let's make that one more time. And I'll be honest, this is probably, especially as projects get bigger and bigger, this ends up being like more and more of your actual compile time is just fixing small typos and where you've modified something in one place but forgotten to modify it in another. Like that just becomes more and more what you're doing when you're coding. So let's see, output. And we have a error, no error. Excellent. So let's go ahead and close that. We'll close video, close our messages. All right, we're going to come back to main, but we can close out error, because error is pretty much finished. So we'll save that. And we can close that. All right, and we're down to just these two files. So the next part about this is actually going to... Okay, the next part is going to be setting up our main loop, which we kind of already have, in a way. It's right here. It is our getCH. Actually, let's... Well, no. Okay, so I do want to remove the getCH. So we also have a couple of other subsystems that we want to install. We've got our video subsystem set up, at least enough for now. Our next subsystem that we want to get is our keyboard handler. So way back in the day, a lot of games and programs in general would just use the default BIOS keyboard handler, which is good for word processors, but it wasn't really good for games, right? Because basically, one, you only ever paid attention to when a key was pressed down. So, like, that's why the early Sierra games, you know, you'd press a direction to start walking in that direction, and then you'd press it again to stop. And that stuff made playing those games really painful because, you know, You're you are fighting the control mechanism, trying to do uh, very careful movement up and down stairs that don't have banisters, and then you always die when you fall off those stairs. That is, yeah. There's a whole thing about that in the Sierra fan base, like just as a joke. So, we need to replace our keyboard handler so that we can have one that's custom tailored to our engine. So what we're going to do is we're going to say new, and we are going to save this as keyboard.c. All right. And we are going to also go ahead and get our yeah. Let's open back up. Oh no, I don't want a .h. I want a .c. And actually, you know what? I should be doing this way. Man, my phone is absolutely exploding. So let's reopen error, which you do just by highlighting it in the project manager. Oh, too many. And then hitting enter. So copy, close that, F6, F6, edit, paste. One day I will actually start being able to do that without looking at it. Man, my phone is blowing up. Okay, so this is going to be our keyboard interrupt. And, Jesus fucking Christ. Okay, I'm muting my phone. There. In fact, can I turn this thing so that it's not... There we go. Alright, no alerts. So, Gorgon 2.0's keyboard interrupt and data fetch mechanisms. Okay, so we've actually got some interesting stuff to set up here. And the first thing we're going to be doing actually is going right up to the top, and we're going to include dos.h. We're also going to need a function in this. We're actually going to need a couple. I don't know if they're functions or macros. Zoom. Okay, so what we want is we want disable, which disables interrupts along with enable. And then we're also going to want, is it in here? Yes. I believe I can just use np. Reads a byte from hardware port. Yep. Okay. So we are going to try and code this entirely in C++ with no actual assembly. So we'll see how well I do. Alright, so the first thing we need to do is we need to create a static void interrupt var star, and we're going to call it old KB. So what this is this is a function pointer that is going to be used to track the old keyboard handler, the one that BIOS has installed or possibly any drivers have installed. We're going to have that kind of set up in the background. So then we can, I'm also going to go ahead and say queue size. Let's call it KB queue size. And we're going to set this to 256. I'm going to tab it because I like the alignment of tabs. We are going to define our keyboard structure. So first thing we're going to do is make a series of shorts. Now, the keyboard sends all of its commands in the form of bytes. And generally, the actual bytes from the keyboard are always going to be 7 bits wide, not 8. Like, it does transmit 8 bits because of the standard, but it's only going to actually use 7 bits. If the 8th bit is set, it's special command words coming from the keyboard. So we are going to go ahead and define our queue as unsigned shorts that will give us 2 bytes per entry. We're also going to create some quick variables to track states of the machine or states of the keyboard. Words falling out of my head. Always adding S's. Don't need S's. Okay. So what we're looking at is we have our escaped value, which will track a specific specific quality. We're going to be looking for if a value has that 8th bit set. If it does, then we'll flag escaped, and we will store this in the high byte of the current queue word, or the currently pointed at word in the queue. And then when the next command is read in, it will see, oh, escaped is there. I will OR the new word into the existing word. That way, it doesn't overwrite anything, and we can kind of get more complex commands. The one situation where that is not entirely going to be true is, I believe, FF is also what is used to signify that a keyboard key has gone from pressed to unpressed, if I'm remembering correctly. It's been a little while, so we're also going to go ahead and actually, you know what? I did that so that I could... I'm sorry, I am actually copying some of this code from notes that I made. Oh my god, am I actually prepared? I'm not. I am not prepared at all, in the slightest. So we're going to define our actual KB interrupt. And so what we're going to do... Oh! Do I? Yeah, okay, no, I do actually need a KB scan, because that's going to track our last command brought in. So first thing we're doing is disable. Is that used as a function, or is that... Yes, okay, it's used as a function. Okay, so we're going to disable interrupts, which should be disabled because we are in an interrupt handler. Interrupts are an old hardware mechanism where when a signal is sent to the processor interrupts whatever code is running. It stores the necessary information about that process, and then goes into a special interrupt handler. And the Intel x86 has a fairly complex hardware level interrupt system, where when it realizes there's an interrupt, it will go and find what caused the interrupt very quickly in about, it's like 4 to 8 cycles or something like that. And it will find out what the actual interrupt is, and then it will use that multiplied by 4 as a lookup into a table in memory for that interrupt's code, that interrupt handler's code. It's a few more steps than, say, something like the 6502, but then it means that it has 256 possible interrupts. So we are going to be taking advantage of that, and I'm going to go ahead and say enable right there to make sure I don't forget. So now what we need to do is we need to say kbscan equals import, and I believe that's RX60. And then I need to... Oh, what is my code doing? Sorry, I'm translating between 2 different languages, because my old code was actually written in assembly, but I kind of want to see if I can write this entire engine without any assembly now. That might be a bad idea, but we're going to try. So you're going to have to bear with me just one moment. Okay, so all right, I'm using a local variable. So we'll say unsigned char b. So b equals import 0x61. Then okay, I get it. So what we're going to do is we're going to say out port, and I believe that's port address first. Yeah, port address first, then the value. So 0x61, and we're going to say B or 80. I believe that's, yeah, 0x80. Okay, and then we are going to outport 0x61B. Oh, right. Okay, so what we were doing was we were getting the status of the module at port 61. We're turning on this to show that we have to tell the hardware we've received your byte, we know what's going on. Then we switch that back off, which is why we're sending it again without. And let's give this a name that's a little bit more descriptive. Status. Okay. So status get is taken from port 81. We're then going to OR it with hex value 80. And then we're going to send back out the original status value. And I am going to remember my semicolons for fear that my wife will come out of nowhere and start going, semicolon. She loves to get me for forgetting semicolons. It's like she she hasn't really gone far into coding, but she loves how frequently I'll sit there and say I've been tracking down an issue and it's taking me forever, and then it's like, oh, I've missed a semicolon somewhere. That's why. Okay. Anyway, so this is what we've been working towards. So then we are going to go kb scan doesn't equal previous. Oh, and I forgot to set this. So that's unsigned short previous equals kb scan. Let's go ahead and break this up so it's easier to read. So if our new keyboard scan doesn't equal previous, then what we're going to do is if kb scan is greater than or equal to 0xe0, else go ahead and get that set up. So this is what I was talking about earlier about the escapes. So we're going to say kb, our keyboard q plus kb.tail equals unsigned short kb scan bit shifted 8. So basically what this is saying is we're going to take the byte we read in and we're going to store it in the high byte of kbq with using the tail as an offset. Tail is a single byte, so we know that that's never going to go beyond 256. An offset of 250, actually an offset of 255, which is okay because we've reserved 256 bytes in our queue. So this is thankfully a very safe way of doing it. We didn't need to store any additional values or do any kind of extra logic, because one of the biggest things when you're doing interrupts is you want them to be short and fast. So it's vitally important to always keep your your interrupts as compact as possible. Okay, so if kb dot escaped equals 0, then star kb dot q plus kb dot tail equals 0. Then star kb dot q plus kb dot tail. You know what? Oh, wow. That's or equals. I think actually a 16-bit addition, or in this case an 8 to 16-bit addition, is probably going to be about as cheap as an OR, but I'm still going to do it as an OR. And then we are going to increase, and actually I'm going to do it the other way around because I really hate... I'm funny and I hate having the plus plus at the beginning. What do you call it? Pre-increments? They just bug me a little bit. I don't know. I'm a bit of a, a codger at this stuff, so. Okay, so what we are going to do then is we are going to create our init function, and I know our video only got v, but we're going to go ahead and make kb here because it honestly makes things a little bit more obvious. Okay, so what we're going to want to do is star BIOS key state. Do I even use it? Oh, I do. Ha 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 ha. Okay. So kb dot escaped equals 0, kb dot head equals 0, kb dot tail equals 0, and kb scan equals 0. Old kb equals, now this is a function that kind of harkens back to what I was talking about earlier about the interrupt addresses that are stored in that vector at the beginning of memory. So it's 4 bytes per address in that vector, and it's got 256 possible values. So what we're going to do is we're going to use getVect and setVect so that we can find where those interrupts are in memory and get them back. So we're going to say getVect, and we need interrupt 9 because that is the PC keyboard interrupt. Keyboard state equals unsigned char far star, make far pointer 0x040, 0x017, and then we are going to key state and equals 32 or 64, disable setVect 9, and then what did I call that? That was keyboard KB interrupt? Yeah, KB interrupt. So KB interrupt. And then we'll re-enable interrupts. Now, most of this is probably pretty self-explanatory, except for these 2 lines. I'll be honest, at this point, it's been so long since I originally added this stuff into my frequently oft-used keyboard handlers. I don't actually remember specifically what it's doing. Basically, we're setting 2 flags in a piece of memory at offset 4017. I don't remember what part of the actual BIOS subsystem keeps track of that, but it does. So yeah, this is just setting some flags that other BIOS operations will be able to, or hardware operations will be able to uh, keep an eye on, just to make sure we don't have any conflicts. I don't remember the specifics about it at this point, because like I said, this this code has been copy pasted from project to project for so long. There's going to be some esoteric things that I've kind of forgotten over over the years. Um, I really should go back and try and look up exactly what that code is doing, and maybe I will, and I'll put a comment about it in the about box for this video. But for right now, we're going to go forward and pretend that I absolutely know everything that's going on in this piece of code, and we're going to say set vect, and we're going to say 9 and old keyboard. So basically, all that kb quit is doing is I should probably actually disable and enable. All it's doing is the set vectors are we're passing it a function pointer and telling it put it at interrupt 9's vector in the interrupt vector segment of memory. And then when we call kb quit, we're just saying, hey, remember that old kb that we got from the BIOS at the beginning? We're going to restore that so that in an ideal world, we are leaving the computer in the same state we found it. Uh, Kind of like how we stored the OS mode, the OS's graphics mode for the text mode, and then restored it to that same mode, not just making assumptions. We're doing the same thing here. We're just trying to clean up after ourselves. So, let's go ahead and save. Now I do need one more function. I need an int kb has key. And what this is going to do is it's going to say we're going to say return kb.tail equals kb.head. We're also going to want an unsigned short. You might be wondering, we've got short and int. Am I returning a 32-bit int for kb has key? And in 16-bit land, no, I'm not. I'm returning an integer. I use short when I'm being specific that this has to be or I want it to be a 16-bit value, whereas int I will use when I don't care what its bit depth is. So we'll say get key, and we'll say return actually, let me do an unsigned short r equals kb.q at kb.head, kb.head plus plus, and then return r. And yes, I could write that all as one line of code, but I hate doing that because I find it looks ambiguous, and I'm not always confident that any given compiler is going to compile it correctly, so I'd rather just write the lines out. Because I'm an old codger at this point. I'm not even 40 yet. But I get curmudgeony with my programming. So what we are going to do is we've got all of these. We now need, you guessed it, another header file. So we're going to say if and if keyboard H, define our keyboard H, and then threndif. Yes, that's exactly it. So what we're going to need here is we're going to need keyboard init, void kb quit, then int kb has key, and then unsigned short kb get key. And we want this to be keyboard.h. Okay. And then, like before, we are going to add our keyboard. And then we are going to close the project so that it saves everything, just in case we run code that then causes the whole system to crash. Reopen it. Alright, so let's go to main, and we are going to add pound include keyboard.h, and then in here we are going to say if, oh, I don't need an if, because this cannot fail, keyboard init, and then I'm going to need to get rid of that, so we're going to say keyboard quit, and what we're going to do is we're going to say while kb has key, and that's a function call. And what this should do is it should tell us whether the head and the tail are still in the same place. Oh, and this should actually be doesn't equal. So this will tell us that the tail has been incremented by the interrupt, but head hasn't been interrupted because, or hasn't been incremented because we haven't called get key. And my sinuses are doing something really weird right now, and I don't know what's going on. I'm going to finish off this video, and then I will go and take care of that. I apologize for if I sound sick. Okay, and we can, I believe we can close that. So, we should, in theory, be good to go. Let's save all. Compile, make. The excitement of compiling in DOS at about 8 megahertz. See, I'm giving you all the true classic programming experience of having to wait for things to compile instead of it just being almost instantaneous. So run. Hey, it worked! Look at that. And if we go to output, thank you for playing. Excellent. So that is our keyboard handler completed. So I'd say we're doing pretty well so far. I'm going to go ahead and cut the video here, and when we come back, we're going to start setting up the next bit of the primary game loop. And slowly but surely, this program is going to become more and more an actual, usable engine instead of just like, a couple of pieces of like almost tech demo-like code. We're going to slowly flesh this thing out over time. So thank you for watching, and I hope you'll be back for the next bit, and we'll go from there. All right?